Hi guys. From the derivation we made of heterogeneous reactions, we understood something now. Okay, for a batch reactor, PFR reactor, sorry, for a PFR reactor, we understood something that tau prime was equals to 1 over k prime ca naught. Okay, into bracket. Now, depending on whether you're giving an assumption or whether you're not giving an assumption. Now, in this particular question, it said in the heterogeneous equation above. So the assumption was already given here. Okay. Now, so that means in solving this particular one, we are going to work with the assumption that was given to us. Now, in a case whereby you are not, if you had watched the other video, you understand what I'm talking about. Now, in a case whereby you are not giving the assumption that integral u over v dv is equals to this, that. Now, when you are not giving that assumption, you should know that you should work with the normal equation, the normal derivation you get. But since we're giving the assumption here, no time to waste, so you can easily say that this becomes 2 epsilon into bracket 1 plus epsilon xa into brackets, okay, 1 minus xa, please do pardon my writing, thank you, plus 2 into bracket 1 plus epsilon xa all squared, okay, all over 1 minus xa all cube, now minus 2 epsilon plus 2. Okay, now this one you have that your k prime, now what's your k prime? Your k prime is same thing as your ks here. Okay, now your ca naught was already given to you. What else again do you need? Your r was given to you. Your, okay, they didn't give you ca naught, but they gave you fa naught. But ca naught is equals to what? P naught over rt naught. So I think this settled. You have your temperature, you have your pressure, and you need just ca naught. They're giving you r, abi? Now this part you have to be very careful. They gave you xa, they gave you expansion factor. Expansion factor is e. So you have e, you have xa. All the things you need inside this bracket are just e and xa. They're giving you e to be 0.2, giving you xa to be 0.6, giving you k prime. The only thing that can keep you from solving this question is ca naught. That's the only thing that can hinder you from solving this question. Now, okay, to make things easier for me, I already have fa naught. Come to think of it, I have fa naught already, and I have p, I have t, and the r is just the major thing. Now for the r, now I want you guys to notice something. Your r here was given in atm, okay, the r here was given in atm centimeter cube per mole Kelvin. So I have atm cm cube per mole Kelvin. Now there's no need for you to bother your head. This was given in Newton per meter squared. Now the closest thing you can get to Newton per meter squared is joules, and everybody knows that r is equals to 8.314, okay, joule per mole Kelvin. By the time you do your whole conversion, Newton meter, cut and all of that, you see that it's correlating to this. So there's no need stressing yourself and converting this. And the worst would be if you use your 83 directly, then you just get the whole thing wrong. So firstly, check your units and make sure they correlate to what you want to do. Now check the most appropriate units. Now the reason why he didn't put the value of r was because this is quite obvious. Everyone knows that r is 8.314. Since you have your pressure to be in terms of Newton per meter squared, you should know that your r will be having joules in it. Now in cases whereby you have, in the other video that we made, whereby we had a more complex conversion, he already gave you the value for r, so there was no need for you to stress yourself. I'm saying you might be solving a question, you might have access to the value of r, but in a situation where you don't have access to the value of r, you can decide to convert. But in this case, there is no need for us going through the whole stress of conversion. So my point being that tau prime is equals to 1 over 0.0649 times my ca naught. So you solve this out and get your ca naught into brackets, then your expansion factor is 0.2, and your okay, the expansion factor is 0.2, and your temperature was given to be 450 Kelvin. That was also settled. And I also had my, what else again do I need here? I've been given expansion factor, I've been given temperature. I think those are the basic things I needed to solve this question. Those were the basic things I needed to solve this question. And we were asked to find the weight. Okay, so it's the weight we actually even looking for, not even the. Okay, now to find the weight, is quite easy. To find the weight, I can just say that tau prime is equals to WCA naught over FA naught. Okay, after getting your tau prime, you have FA naught, you have CA naught. Now if you calculate correctly, you should get your CA naught to be, your CA naught should give you 52.85 mole per dm3. Now you might not get this exact same answer. Why? Because here the R that was used here is 8.409, which is almost the same as this, but just to be safe, I'll advise you use 8.314 for your R. So you get the value of your R and substitute in, so you should be getting something close to this. It might not be exactly this, but you should be getting something really close to this. So then you solve out. Then after getting value of your tau prime, equate it to W C naught, so you can easily find your W. I can then say from here, okay, I can easily say that my final W will be equals to, I can say my final W will be equals to let's see, tau prime times FA naught over CA naught. So this I get your final answer. I'm so sorry I cannot calculate it out, but this is in order to ensure that you're also participating in this. So just use your calculator to confirm your answers, and frequently I'll be posting the answers, and if you have any questions, contact me. And if your answer doesn't correlate, just let me know what's happening so that we can work through it together. Thank you very much. I hope you understood what I just did now. Bye.